Yes, hello, greetings. Welcome to my channel. Today I would like to demonstrate how I will be welding using the andelli 270 TBL spot. And yes, that's why I modified my burner here. The problem was that I could never see properly when spot welding. Where is the center of the seam? But I can do that here now. Wonderful. Here with my glass nozzle. Understandably, that's why I wanted to convert my burner. Did I make a video too? Yes, you can also have a look. I had to make this adjustment here. It seems a bit unprofessional. I used epoxy resin to fix it because initially I thought the switch was insignificant. However, it's absolutely necessary for spot welding since it allows for quick pressing. If you had a button like this one, positioned on the burner, it would indeed pose significant problems, I believe, to operate it correctly. So you can hold it comfortably and simply flick through, and mock nicely. Yes, that's why I adapted it. The burner that was previously installed was the Cuckoo 150, indicating that it was a unique model. The glass components for it are not yet available. Yes, I now have WP17 in front of me. I used it back then for lift welding, where you just open the valve here. Yes, of course I have the valve open now so that the gas can flow out. But now the machine controls the gas supply like this. I've repaired it. And yes, let's examine how I welded the spot. So the very first thing I did was to lay down 1 or 2 chrome nickel sheets and begin welding. The first thing I'm going to do now is apply pressure. Please allow the gas to flow. And then, here you can already start filling it in a bit. Then I'll start imitating now. Always, half a lens or a quarter lens is best. Give it a little time. Want or need to generate too much heat. So then I would really wait for 10 to 15 seconds between the spots. It's a lengthy process, but I'm going to say it now. Overall, it always depends on what you want to achieve in the end. First and foremost, I'm absolutely thrilled to be here now. Gas lens. I consider myself to have somewhat optimized my approach here. Of course, there would also be a foot pedal. This surpasses the toothpaste tube, where you could firmly hold the tube with both hands and just press the foot pedal. But overall, I find this welding technology very interesting. So, these are things that I used to struggle with and I didn't do them. I managed to use this device so wonderfully today. Yes, and gradually, step by step, you see your caterpillar reach its destination. In the West, you sit directly in front of the piece to be molded and view it from the front, pulling the clay towards you. And you can see it at its best. But now, here with the camera, I didn't have the options. Resting a little would be better. That's why the spinach is still a bit restless. But it's still handheld and you're always pushing. I'll call it off. I also get a bit confused in the process, but I say that practice makes perfect. Yes, I believe the entire thing can certainly be enhanced. The spacing of the nozzle is important. I'm going to comment on that right now. The distance between the nozzles. So I've experimented with a few things now. It always depends on what you are welding, which material. In any case, I would suggest that the tungsten electrode should recede about 1 millimeter to half a millimeter behind the Pyrex glass. Then it is essentially optimal. So now we're working here with chromium nickel steel. Is this the optimal setting? You simply need to make a few attempts depending on what you aim to achieve. So I would say chrome nickel steel is quite straightforward. That really is one of the easiest things to hide here with the advertisement. I must state this very clearly. And since most items, such as chrome nickel steel, are welded, yes, it's relatively straightforward. I'm about to weld copper to regular steel, and then I'll attach the copper to the central steel as well. Can we watch? That is also interesting. It really does work. Yes. Here we can see that I have become a bit more experienced. This is the seam, smooth and steady. I'll take more time. Yes, and you can already see the beautiful scaling here. I became a bit more impatient towards the end. The lenses are slightly larger. It's all just a matter of handling. So now I have clamped a sheet of copper here. I have made a mistake. I didn't really pay attention to cleanliness, so you really must. I have a standard 235 steel sheet here, as well as a regular copper sheet. You need to clean both sheets and then you need to spot check. This then works relatively well, but as I mentioned, I wasn't concentrating on cleanliness here, and that's why I encountered a bit of a problem somewhere in the middle. It didn't go as planned. But if it's truly clean, it's also remarkable how well you can use it to connect things. And it's really firm. Yes, but essentially here as well. A distance of approximately 0 to 5 millimeters behind the Pyrex glass eyelet. I had to exert a bit more effort here, as the copper sheet naturally absorbs a lot of energy, thus requiring a higher input. The higher the setting, the stronger it becomes. Also, feel free to adjust the timings a bit. It can definitely be optimized further, but I really just wanted to demonstrate that it functions. It's astonishing that you can simply blend these metals like that. Yes, as I mentioned, I'll be heading to the other side shortly. The chrome nickel plate. Und let's see if it's similar or if it might even work better. I encountered a bit of a problem here in the middle, where there was some dirt, as I just mentioned. Naturally, I didn't work cleanly, which led to a few issues. That's somewhat permeable. Yes, I genuinely attribute this only to my incorrect handling of the base material. I should have sanded it down a bit better. But what's interesting is that if I weld the chrome nickel plate right now, it performs much better. This is likely because copper, chromium, nickel, and steel have a face-centered cubic structure. In this instance, both copper and the steel type 235 exhibit a face-centered cubic arrangement. I could imagine that it has something to do with that. Yeah. I'm about to finish up here. Then we'll quickly examine the chromium nickel plate. That's how it worked. So here we can clearly see how well it's already starting. And there are some really nice lenses. Here with the committee and the copper sheet, that works wonderfully as well. Nice and even, that's very simple. On the whole, however, this is a fascinating technology. I mean, if I examine it a bit more now, delve a bit deeper into something, you can truly accomplish the most extraordinary things with it. I'm really enthusiastic about it. And the machine does it really well. So, here I have the three metals welded together again for you to see. The result turned out quite well. Chrome on the right, nickel on the left, and here I have blended it in. Yes, and then there are some more nuances. This is now about steel and copper again. Yes, and with that, we've actually come to the end. I hope you enjoyed it. I wanted to show you something pleasant again. Don't forget to give it a thumbs up and subscribe. And then I would say take care. See you next time. Bye.